Buongiorno a tutti, sono Mariagrazia Brunetti di Quence e sono lieta di ospitare in questa nostra presentazione della mattinata Ingo Philipp di Tricentis, che fa parte del Product Management Team, ma al di là di questo è un guru per quanto riguarda le metodologie e le tecnologie legate proprio all'agile testing e al continuous testing, che appunto vi parlerà di come il continuous testing è un argomento fondamentale nella digital transformation. Sono lieta di ospitare quest'anno Tricentis al mattino e nel pomeriggio faremo una presentazione, un workshop insieme ai nostri partner Atlassian, Neotis, Tastop e Tricentis, in cui illustreremo proprio la nostra visione di come poter supportare i nostri clienti nell'implementazione delle nuove metodologie Agile e DevOps. Faccio solo una brevissima presentazione su Quence e poi lascerò subito la parola a Ingo. Quence è stata fondata nel 2014 da un gruppo di professionisti che provengono dal mondo dell'ingegneria del software. Abbiamo quasi 5 anni, ma in realtà siamo ancora una start-up e della start-up condividiamo l'entusiasmo nel nostro lavoro, in particolare legato alla quality assurance e il costante orientamento all'innovazione e nel cercare delle nuove opportunità sia in termini di prodotti che in termini di metodologie. Il nostro obiettivo è quello di coniugare delle competenze metodologiche, di processo, formative, con delle soluzioni best in class che noi abbiamo scelto in ambito europeo, alcune in ambito mondiale, alcune le abbiamo portate proprio noi in Italia, nell'ottica di aiutare i nostri clienti nella transizione verso l'innovazione che è richiesta dalla trasformazione digitale che è in atto. Giusto per darvi un overview dei nostri primi anni di vita, siamo nati nel 2014 dove abbiamo iniziato con la partnership con Tricentis, che si è rivelata una partnership vincente, perché in questi anni Tricentis si è proprio confermata sul mercato come uno dei maggiori leader nel campo del testing e della test automation. Poi nel 2016 abbiamo cominciato ad ampliare le nostre partnership siglando una partnership con Atlassian per quanto riguarda l'application lifecycle management e con Neotis per il performance test. Nel 2017 abbiamo consolidato ulteriormente la nostra partnership con Tricentis e quindi siamo diventati premium partner e abbiamo fatto una partnership con Tastop per proprio riuscire a completare l'integrazione, la continuous integration soprattutto dei tool nell'ottica di poter automatizzare e sincronizzare i dati su dei tool diversi. E nel 2018 abbiamo siglato una partnership con Parasoft per completare le nostre soluzioni per quanto riguarda l'analisi statica del codice e il cosiddetto language testing. Abbiamo acquisito molti importanti clienti in questi anni con cui stiamo affrontando dei progetti molto sfidanti e molto importanti. Vorrei appunto ricordarvi che nel pomeriggio abbiamo questo workshop in sala Scala 4 alle 14:45 e quindi se volete approfondire vi aspettiamo. Now it's your. Let me introduco Ingo Philipp.
Thank you so much, Mariagrazia. Give it up for her. So this is actually the last slide, guys. Really? So can you switch to the first one? But you know, we are here to resolve software fails, so this is business as usual for us guys, right? So first of all, thanks so much again, Maria. And of course, many thanks to all of you guys. I'm just more than happy to be here. Honestly, that's my first time in Milan. But I'm definitely more happy that you are here. And you can't imagine how happy I am that you are here, guys. Around 4 weeks ago, I was around in the US and I was invited to give a talk at the Star East conference in Orlando. And they gave me a room for 500 people. And you know what? 5 people showed up. So you can't imagine how happy I am to have you in that session. So thanks so much for coming. Now, in this session, I don't just want to demonstrate why digital transformation requires continuous testing. I also want to show you how we put it into practice. So that's the master plan. That's what I want to share with you. And in order to dive into that topic, let me start with this. Guys, we are all surfing the same wave, right? The big tsunami of the big money, now called digital transformation. And in 2014, Forrester already reminded us for the 10th year in a row that every single business out there must continuously create new customer value at an ever-increasing operational speed. And how do we do that? Well, by exploiting digital technologies. And a digital technology is any kind of technology that generates, stores, and processes data in terms of 2 states, 0 and 1. Now, what's that? Well, that's software. And so software definitely fuels the fear of digital disruption. And therefore, digital transformation is a software-led transformation. Now, that's good for us because somebody needs to test that software. I think that's the reason why we are all here today. But the question is, why do we need to do that so fast? Why do we need to implement, test, and ship our products so fast? Well, the reason, at least to me, is fairly simple. All of our businesses is just about one single thing. It's about a value exchange. A value exchange between your company and your customers. Now, how do we play that game? Well, the first thing we do, guys, is we try to identify the needs of our customers, their wants. We try to uncover their requirements, their pain points. We try to understand their problems. Now, once we did that, we then move on and build a solution for their problems in our software products. And we need to do that fast, right? Because the competition is just a single click away from us. Now, once we did that, we ship our software products to our customers. That means we add value to our customers by solving their problems. And our customers provide value back to us by paying for what we have built or by providing data, right? The new oil out there. Now, while we are building that software product, while we are building the solution, we usually wrestle ourselves through multiple times in ever-decreasing cycle times at ever-increasing speeds through the entire delivery pipeline in order to accelerate that value exchange. So the question is, how did software development now reacted on that? Well, guys, in the past, which still is the future for most companies out there, the entire software delivery process was carried out in separated phases. Phases which didn't know from each other until the previous one completed. And so we call those phases the walls of confusion. And so it's absolutely no surprise that when critical defects were found in those later stages, this often caused the product to be rethinked, to be redesigned, to be re-implemented, and to be retested. And so this then stretched the entire delivery pipeline. And for that simple reason, then most of the companies decided to say goodbye to those traditional waterfall-like approaches, and they said hello to more incremental and or iterative approaches to software delivery. Now, one of which is the rational unified process. And the overall goal of these processes was to parallelize all the activities that were going on in all those phases. But basically, they failed on a fundamental level to resolve this issue. And so around Y2K, then also the large companies adopted agile development and delivery processes like Scrum, Kanban, LESS, the Scaled Agile framework, or the Spotify model. And this fundamentally changed the way how we develop software. Because we moved away from following rigid rules and we decided to evolve in flexible frameworks. And I think that's perfectly described by the principles of the Agile Manifesto. But these companies then quickly realized that product increments developed by product development caused then severe problems on the operations side. And then the blame game began, right? And all this then gave rise to the DevOps movement around 2007 or 2008. Now with all that, guys, I just want to say that we've moved away from revolutionary software delivery processes and we've moved towards evolutionary software delivery processes. Now why did we do that? Well, you know, Darwin already knew it, right? It's not the strongest that survive, nor the most intelligent. It's the one most responsive to change. And this is especially of importance for software development. Because to overstate the case a bit, software is not written, guys. Software is rewritten these days. And so it's no longer about mastering continuous improvement. It's about mastering continuous change. And now let me show you how we can account for that rapid change in our testing project. And let me show you that based on a customer project we already started off 2 years ago in the banking sector. Now this project was all about securities trading. That means trading of financial instruments such as shares, bonds, funds, derivatives, metals, and stuff like that. And the initial condition of that project was that all of testing was in manual testing. So there was not a single automated test case in the regression test set. Now in that project, about 11 manual testers were around. And those 11 manual testers, they had to execute and to maintain about 5,000 end-to-end regression tests, scattered across more than 11 different technologies and platforms. And it took those 11 testers about 10 weeks to just execute that regression test set. And had no idea about the risk coverage. Now the interesting story about that example is that this company wanted to move away from their traditional approaches towards a more agile approach. So they wanted to be able to ship a potentially shippable product in just a single week. But they had no idea how to do that. And so they just gave us this project chart that they just told us, Ingo, there's definitely a way to do it better, find it. And we accepted the challenge. So let me now guide you through step by step what we did in order to transform the test approach. So guys, the first thing we did is we captured, structured, and most importantly, we prioritized all the requirements that were part of the game on the level of themes, epics, and user stories, for example. And then we just took those 5,000 test cases in chunks and mapped it onto these risk-weighted requirement structures in order to make the risk coverage transparent. Turned out to be about 40% at that time. And that now sounds pretty bad, right? But indeed it isn't. Because all those test cases these guys have created were created completely intuitively. So there was no methodical, no structured approach for test case definition that plays in that project. So this took us 2 days or so. And in the next 2 weeks, the next step was clear. We then decided to apply a structured approach to test case definition, which we call test case design. Now, just by doing that, we improved the regression test set in 2 ways. The first one, we reduced the number of test cases by a factor of 4, while we were increasing the risk coverage close to 90%. And there was no black magic involved here, guys. So what we have seen were 3 things. Number 1, we've seen so many high priority requirements. That means, for example, epics that contribute most to the overall business risk. And these requirements were completely under-tested or no tested at all. And we've seen so many low priority requirements completely over-tested. Loads and piles of test cases assigned to those low priority requirements. And in addition to that, the redundancy level in that regression test portfolio was dramatically high. It's about 75%. And this is not the exception from the rule, guys. We see it day in and see it day out whenever we arrive freshly at our customers. Now with all that, we then reduced the execution time just by doing this to 5 weeks. And then obviously, guys, we had a problem, right? We reduced the number of test cases by a factor of 4, but execution time just went down by a factor of 2. Now that would then imply that every newly designed test case takes twice as long as before to execute. That means basically we just fucked it up, right? We made the situation even worse. And we analyzed that for 1 day, for 2 days, for 3 days. We didn't find the root cause. And after 3 days, those guys came to me and said, hey, Ingo, sorry, we never managed to execute those 5,000 test cases in 10 weeks. We didn't even know that we had so many test cases on the regression test set. We just managed to execute about 50% of them, and then we were happy again. The next step was test data management, a solid concept for test data management to make automation repeatable. Now what we did here is we created about 85% of all business objects synthetically. And by business objects, I mean the customers in their banking application, their cash accounts, their custody accounts, or even some of the financial instruments. And the rest of those business objects was then supplied by mass production data. And just by doing that, execution time went down to 2.5 weeks. Now this implies that these guys have spent 50% of their valuable testing time just trying to find the right test data for the test cases during test case execution. And here we are still in manual test execution, guys. Not a single automated test case was written at that moment. We just tried to provide a solid basis for test automation. And that is what we definitely achieved here. And then we went on to test automation. So what we did is we applied our model-based test automation approach. Have a look at it at the booth, how it looks like. We achieved about 90% test automation degree in total numbers. Now 2/3 of all those test cases were based on APIs, on application programming interfaces like web services, to scale the test execution to almost any arbitrary level. And by doing that, execution time went down to 48 hours on a single machine. And then we also distributed those test cases across multiple virtual machines and physical machines in the test labs. We used 6 of them to reduce execution time, full regression, down to 8 hours. So we already moved from 10 weeks or 15 or 17 weeks down to 8 hours, full automated regression. And then we also extracted a smoke test portfolio to continuously test the basic functionality of our applications. Now, how did we do that? Well, we searched for the most important 7% of all those test cases. And the reason why we were even able to do that was that we applied a risk-based testing approach, not just on the level of requirements, but also on the level of test cases. So that means we were able to find these test cases that contribute most to the overall business risk. And we took those 7% of the test cases and then embedded those test cases into the smoke test portfolio. And with that smoke test portfolio, we were able to cover 50% of the business risk, just with this small set of test cases in about 30 minutes to 1 hour. And this smoke test portfolio was then taken and embedded into the CI and CD pipeline. So that means it was executed on demand multiple times a day, but also in periodic time intervals, in nightly builds. And that is how we enabled continuous testing, guys. But the best result we achieved, and that was the reason why we were there, was we were able to reduce the critical defects in production by more than 70%. And that is what we have measured over 1 complete year. Now, of course, it's tough to assign a specific method, a discipline, or heuristic to what has caused that, but my gut feeling says that it was a structured and methodical approach to exploratory testing. So that means the tester, again, learned how to test and not just how to automate. Now, guys, with all that, I don't want to say how cool and how hip we are here at Tricentis. I just want to say that it's not a big deal to achieve that. All this just took us 3 months with just 2 persons, 2 manual testers, okay? So with that, I also ask you guys to transform your traditional approaches for great agility, because the future doesn't just happen, it gets happen, so make it happen. Thank you so much.